Hi all. In this video, we are going to see a paper titled "Very Deep Variation Autoencoder," which can mimic as an autoregressive model and can outperform those traditional autoregressive model like Pixel CNN on generating images. So, what this paper says about? So, this paper says about that autoregressive models and like Pixel CNN or a variation autoencoder models belongs to a class of likelihood-based models. But an autoregressive model has certain advantages in terms of giving a higher likelihood compared to the variation autoencoder. So in terms of that, it could give a better quality images while generating from their network. So this what asked, can we set up variation autoencoder architecture similar like a hierarchical architecture, which can able to act similar to that kind of vanilla autoregressive model like Pixel CRM models. So in that aspect, this paper tries to make a variation autoencoder with more stochastic layers compared to the previous work which hasn't been explored similar in this similar platforms. So they try to uh, see how far we can make a hierarchical variation autoencoder, increasing the depth to up to a layer of 70, and in that aspect they try to find out through an empirical experiment that compared to the pixels this hierarchical variation autoencoder with stochastic layers has a fewer parameters which can able to generate samples much quicker time, and also can scale to larger images with producing high fidelity data output. So this is the overall brief overview of variation autoencoder, which has a generator, a prior, and approximator. So the approximator and prior are parameterized, and that can be trained to using optimization based on to maximize the evidence flow along, which is being described in the equation one. And we know that traditional autoencoders, variation autoencoders, are usually tries to output fully Gaussian functions. But if we can able to make a richer architecture, like making hierarchical latent variables from layer from bottom to up, and which depend upon each other through a conditional like a kind of a Markov chain. So we can able to have a richer architecture. Uh, that kind of setup can give a better resolutions and a better output compared to the vanilla variation autoencoder. So this autoregressive model can setup can also be done using in a decoder setup where each observations can depend upon the other observation. But this hasn't been done in this setup. Instead of that, we are focusing on an encoder setup to make variation order encoder to work similar to kind of an autoregressive model, like making a hierarchical latent representations, which is represented in these equations 2, 1, 3. So it is like a conditional dependence. So this joint can be made through the conditional dependence. So this has been done in the work by top-down variation autoencoder, which is beautifully represented in the picture uh, 3. So this is bottom-up approach, and it produces a lot of latent representation that has been again taken in as an input in a top-down path and tries to make a reconstructions in the data. So this is what is all architecture about. So residual block is used for a bottom-up approach in the encoder side, and top-down approach has a conventional part which has been briefly described in this diagrammatic representations. So this is what this all paper is about. So to be condensed, so they make a hierarchical variation autoencoder in an encoder setup having many stochastic layers which is interdependent. By through this stochastic layer, they could instead of one single latent representation, they have a bunch of latent representation which depends upon each other through a kind of structured dependence that z1 depends upon 0, z2 depends upon other through these equations 2 and 3. With this setup, they claim that this would able to perform similar to kind of autoregressive models like pixel CNNs. and and through some empirical experiments in the later part of the sections, they proved that this have a good producing good quality images similar to the pixel CMS. So that's how this paper is about, giving an overview representation. Thank you.